All right, it is time to talk about periodic law and also a brief history of the periodic table. So let's get started. All right, here are our objectives. Pause and peruse if you so wish. All right, John Newlands. Here's who we're going to talk about first. All right, he was an English chemist. He arranged the known elements in a table, okay, by properties based on atomic mass. And he developed something called the law of octaves. So he realized in lining up these elements that properties of elements seemed to repeat about every 8 elements, hence the law of octaves. Okay, so thanks, John Newlands. So how did Newlands arrange the elements in his table? Do you remember? Yep, by atomic mass. And then he realized in that process that they were actually arranged in octaves, right? Repeating properties every 8 elements. Okay, Dmitry Mendeleev. He was a Russian chemist. He used Newland's observations and other information. So he produced the first orderly arrangement or periodic table of all known 63 elements, and he arranged them by their atomic mass, similar to what Newlands had done. However, he switched up iodine and tellurium. He lined them up according to their properties, not their atomic mass, but he couldn't really explain why. Okay, he didn't really know why he had to do that. He just knew it made sense. Okay. So here's a rough overview of what his periodic table looked like. Okay, so let me just show you. Here he has group 1, group 2. You can see this has elements that are currently in those groups. Group 3, on our modern periodic table, you notice this lines up with group 13, group 14, group 15, group 16, group 17, and then he doesn't have group 18, he has group 8. Group 8 contains a lot of the transition metals, okay? And you'll see it does not match exactly our periodic table, however, it's pretty darn accurate, so kudos to Mendeleev. So something else that is important to note about Mendeleev's table. He has gaps for not yet discovered elements. And he predicted the properties of those missing elements. In fact, he named them. Like he named an element aluminum, so close to aluminum, but not aluminum. And he predicted the properties. And you can see from this table that some of the elements that he predicted, his predicted properties were surprisingly accurate for elements that he didn't even know existed. So Mendeleev, amazing. And why did Mendeleev leave blanks in his periodic table? So he left blanks. Why did he do it? Yep, for the undiscovered elements. How did Mendeleev arrange the elements in the periodic table? So how did he put them in order? Remember, it kind of looked like this? Yeah, by atomic mass, with a couple exceptions, right? He had to switch up iodine and tellurium, for example, but basically by atomic mass. Now we move on to Henry Moseley. Okay, he was an English chemist, and he studied the X-ray spectra of elements. So remember we talked about the line emission spectrums? He studied those. And in that process, he realized that when elements were arranged by atomic number, remember that's the number of protons in an element, not atomic mass, the discrepancies that Mendeleev had that he couldn't explain, poof, gone. So he's like, oh, ta-da, we have to arrange them by atomic number, not atomic mass. So how did Moseley arrange the elements in the periodic table? Yeah, by atomic number. And this is called the periodic law, which we're going to talk about. So the periodic law. When elements are arranged according to their atomic numbers, elements with similar properties appear at regular intervals. Okay, so the physical and chemical properties of elements repeat, and they're functions of their atomic numbers. So when we put elements in order by their atomic numbers, we will see a repetition, okay, of physical and chemical properties. Why do the properties repeat? Well, you look at the electron configurations. The elements in each column or group have the same number of valence electrons. Remember, the electrons in the outermost energy level. And the valence electrons participate in chemical reactions. So not earth-shattering, but elements with the same number of valence electrons tend to react in similar ways, hence have similar properties. So the S and P blocks. So the first two groups, they're colored in blue here, and the P block, they're colored in green here. Those electrons fill sequentially. So we put one in S, then the second one in S, then we put one in P, two in P, three in P, like that. So that's what I mean by sequentially. They just fill them in order. There's no weird rule, exception, anything like that. So the valence electrons are predictable. Group 1 has 1, group 2 has 2, group 13 has 3, okay, and so on. So what is a group? Okay, you can see here group numbers here, 13 through 18. A group is a vertical column, okay? So on our reference table, literally it says the word group. Don't have to memorize it. Elements in the same group share similar chemical properties. What is a period then? Well, you can see those numbers 1 through 7 here. Again, you can see also the word period on the periodic table that we use, so you don't have to memorize it. It is a horizontal row on the periodic table. Elements in the same period have the same number of occupied energy levels. So period 1, electrons only in energy level number 1. Elements in period 3 have electrons in energy level 3, energy level 2, and energy level 1. What information does the periodic table tell you? Well, look at this key. Look at all the information that you can find. You can find oxidation states, atomic mass, the symbol, the atomic number, and the electron configuration. Again, this key is literally from the reference table that we use. So you, again, don't have to remember. What does it tell you? What is a vertical column on the periodic table called? Do you remember? A group. Groups are vertical. What is a horizontal row on the periodic table called? Do you remember that? A period. Periods go horizontally. And why do properties on the periodic table repeat? Do you remember? Do you remember why they repeat? Elements in the same group have the same number of valence electrons, which that is what accounts for the repetition of properties. And there you have it. That's periodic law and a brief history of the periodic table. And guess what? I hope you learned something new today.